Welcome back, students. So in this session we are again going to do some basic operations on the vectors, but whatever we are going to see in this session is very important as far as the physical aspect is concerned, because whatever you are going to learn in this session, you will be using continuously these techniques in the upcoming chapters in physics. So please make sure that you understand these concepts very well, so that it will be very handy when you go for some numerical problems. So to begin with, what exactly is the resultant of a vector means? Even in the previous session, I have just mentioned it, that resultant is nothing but similar to adding the vectors. I am going to show you how it is done and what is the physical aspect behind this. So just look very carefully. I'll just take a small pillar. So this is the pillar and you are looking at the pillar from the top. Assume it like that. I'm going to tie a rope to it. I'm going to tie a rope to the pillar and I'm going to pull it to the right with a force F1, and I'm going to pull it to another direction with a force F2. Imagine that this pillar is free to move about. Okay, it can move in any direction. So just by applying these two forces, how do you think this particular pillar is going to move? Do you think it is going to move along F1 or it is going to move along F2? Definitely not. This pillar will move in between this F1 and F2. This is called the resultant of these two forces. Resultant. Because of these forces, this is the resulting force. That is what I am trying to say. So whatever I have mentioned in here is the direction of that force. You can just ask me a question, sir, then what will be the magnitude of the force? What do you mean by magnitude again? I said that magnitude is nothing but the length of that vector. Okay, what is the length has to do with the force vector? Which means how intense your force is going to be. For example, I say that the force applied on the body is 3 newtons, 4 newtons, 5 newtons. That 3, 4, 5 which I talk about is the magnitude, and this will be the direction in which that much amount of force is expelled. So how to represent this Fr? Fr is directly represented as root of F1 squared plus F2 squared plus 2 F1 F2 cos theta. What is theta, by the way? It is nothing but the angle between these two vectors. Angle between F1 and F2 is what this theta is. So if you just apply this formula directly, you will get to know the magnitude of this resulting force. And remember one thing, this F1 and F2 are not the vector quantities, but the magnitude of these two vectors. Okay, so just by applying all the values that you have it with your hand, if you plug it in, you will directly get the resultant force. Okay, now what I am just going to do is, I am going to show you what is the physical aspect behind this. Listen very carefully. I am going to rearrange the vectors. Look how I am going to rearrange this. This is Fr and this is your F1, this is your F1. If I take this F2 and if I place it here, what happens? Your F2 comes in like this. See, what I just did was, I took this F2 from here and I have placed it here. Those things are allowed. Unless or until you don't change the direction of the vector, you can place it anywhere you want. So what I just did was, I took this F2 and I just placed it in here. So the whole diagram might look like this. I am not so accurate about drawing this. Okay, please listen. So this is how you get this. By seeing this, what do you understand? Again, very simple. Listen. F1 the head of the vector f1 is in contact with the tail of f2. So you are allowed to add these two vectors. Okay, you are allowed to add these two vectors. In the same way, the head of your f2 and fr is in contact, so those two vectors will not get added up. So how can I represent this? f1 bar plus f2 bar is equal to fr bar is equal to fr bar. This is how you represent this. If I take the magnitude on both the sides, I will end up with this formula. So from this I can prove that resultant of the vector is nothing but a process of adding two vectors. Again I will give you an example to establish this fact. Let's assume that both the forces are equal and the angle between these forces were 0 degrees. So what do you think is the resultant of these two vectors then? Same thing, f squared plus f square plus 2f square cos 0 is 1. So root of 4f square is what you get, which is equal to 2f is the resultant. 2f is the resultant when both the forces are equal and both the forces point in the same direction. You remember in your schools, your teachers usually say when the vectors are in the same direction you are allowed to add them, and if the vectors were in the anti-parallel direction opposite to each other, you are supposed to subtract them. That is not because of any rule that they are talking about, but they are trying to take the resultant of those vectors. Literally, they are trying to take the resultant of those vectors, but fortunately they end up adding them. Okay, and one more important thing, a very important thing. Only if the vectors are in the same direction, only if the vectors were in the same direction, you are allowed to add them algebraically. Okay, in case if vectors were in some arbitrary directions like 30 degree, 60 degree or something like that, in that case you are not allowed to add them algebraically, but you should directly go to this formula to get the additive vector. Okay, you should not just algebraically add them even if they are going to be in some other arbitrary angles. Remember, that is very, very important. So this is how the resultant is given. First thing, resultant means adding up vectors. What happens when you add two vectors? You will end up with another vector which is pointing exactly in between these two vectors. First thing. Then what is the magnitude of those vectors? It is given by this formula. Okay. So by using this formula, you can add any vector you want. But the only thing that you are necessarily need is the magnitude of those two vectors and the angle between them. If you are aware of these three quantities, you can directly find the resultant of any two vectors. First thing. Then next question will be asked. Sir, this FR is between F1 and F2. Fine. Okay, that is fine. So where does this FR leans to? Is it closer to F1 or is it closer to F2? Remember, depending on the magnitude of the vector F1 and F2 is the angle between the FR and the vectors will be. That is, I will call this to be alpha and I will call this to be beta. What I am trying to say is, in case your F1 is greater than F2, your F1 is greater than F2, then alpha will be less than beta. Your alpha will be less than beta, which means your resultant is leaning towards F1. Your resultant is leaning towards F1. That is what it is. Okay, so I'll give you another formula to find this alpha. I'll give you a formula to find alpha, where alpha is equal to F2 sin theta by F1 plus F2 cos theta. See, a very simple formula. I am trying to find alpha. Alpha is the angle between the resulting force and F1. So, since I am finding the angle between F1 and Fr, this F1 should not appear in your numerator. Okay, that F1 should not appear in the numerator, but the other vector that involves should come in your numerator with sin theta divided by F1 plus F2 cos theta. Okay, just a point to remember in this formula is the force that you write in your numerator should not be the force along which you cut the angle. Okay, so how to find beta? Beta is simple. Theta minus alpha is beta. Theta minus alpha is your beta. So you don't have to necessarily do that. It's enough if you find your alpha directly. So this is all about your resulting vector. Okay, so now I'll directly give you few identities that you should remember. Okay, because these identities that you are going to remember will be very helpful for you when you go for different chapters like gravitation or electrostatics or whatever you do. It will be very helpful for you to solve the problems without even writing a single step. Okay, see, I'll assume Fr is what I am going to find. Okay, the two vectors that are going to involve in that are going to be equal like this. Let's say these are F1 and F2 and theta is the angle between them, and I assume that the magnitude of these two vectors are equal. Then already we know that Fr is equal to root of F1 square plus F2 square plus 2 F1 F2 cos theta it is. So I will try to substitute everything. Fr is equal to, for 0 degree, if your angle theta is 0 degrees, if your angle theta is 0 degrees, what happens then? It becomes 2 times F, and then if your Fr, when your theta is 60 degrees, what happens? If your theta is 60 degree, then it becomes root 3f, and then Fr is equal to, when theta is equal to 90 degrees. When your theta is 90 degrees, the third term completely goes 0. So what you will be left with is root 2 of f. Root 2 of f. Then if your theta is 180 degrees, then your resultant will be 0. Your resultant will be 0. So it's better you remember all these identities. I'll give you another one. When the angle between them is 120 degrees, the resulting force will be F. This identity is very important, the last one. You see, when the angle between the two vectors are 120 degree, the resultant is going to have a magnitude equal to the magnitude of one of the vector. So Fr is equal to F for 120 degree. So this is the only angle for which the resulting vector is going to have a magnitude of the vector, any one of a vector that is involved. So with this note, I'll just finish this session. In the next session, we are going to deal with a very important topic which is called resolving the vectors. I hope you watch that session too. Thank you.